A very good morning.
Good morning, teacher.
Do you have any questions in trigonometry before I introduce a new identity? Any questions? No questions. The double angles and multiple angles. Now, to start with, I will need to remind people here that if you look at our previous definitions of compound angles, we saw cos of A plus B defined as cos of A, cos of B, minus sine of A, sine of B. We have seen cos of A minus B as equal to cos of A, cos of B, plus sine of A, sine of B. We have also seen sine of A plus B as the same as sine of A, cos of B, plus sine of B, cos of A. Sine of A minus B is equal to sine of A, cos of B, minus sine of B, cos of A. Now, if we want to double the angles, or perhaps get an increment of the angles, then we can get new definition. Let us start with what we call the double angles. Double angle, trig identities. Just like you hear the word double angle, it means you're doubling the angle. That is, if I let AB equal to B, AB equal to B, if A is equal to B, then A plus B would be the same as A plus A, and this will be 2A. If I confirm that, where there is subtraction, of course, we shall get 0, so you don't consider the subtractions, we shall only consider the additions. So we shall have cosine of A plus B. We have seen is cos A, cos B, minus sine A, sine B. This will become cos of A plus A is equal to cos of A, cos of A, minus sine of A, sine of A. Where there is B, you're putting A. Then this side you'll have cos of 2A, so the angle has doubled. That's why we call these ones double angle trig identities. So this is going to be equal to cos squared of A. When you're writing squared, the square is written between the trig function and the angle, minus sine squared of A. That is the first definition for the double angle of any angle. But recall, we have seen sine squared A plus cos squared A is always equal to 1, meaning sine squared A can be equal to 1 minus cos squared A. Therefore, double angle of 2A can be got from cos squared of A minus, where there is sine, 1 minus cos squared of A, and this will reduce to cos of 2A will become cos squared of A plus cos squared of A minus 1. Therefore, cos of 2A is actually going to be equal to 2 cos squared of A minus 1. So this is another definition of double angle functions. Identities in terms of cos. So this is a double angle for cos, and in general, we can say cos of 2 theta is always equal to cos twice of theta. Is equal to twice cos squared of theta minus 1. The idea is cos of an angle is equal to twice cos squared half of that angle in the definition minus 1. Why am I bringing in the concept of half? It is because the original angle is 2 theta, then the angle here is theta, we have half theta. So what if I have cos 4 theta? It will become twice cos squared of 4 theta minus 1. Rule 2, what if I have cos of 6 theta? What shall I have? Rule 2, Leila?
I've just entered class. Please repeat.
Rule 2, you were there, don't lie. Eh? Why are you lying? You've just entered. Akankwasa Maria, were you there?
Teacher, I've also just ended.
Come on, guys. Okay. This is going to be 2 cos squared 3 theta minus 1. We are saying the definition for double angle of cos is cos of an angle, the angle is now 6 theta, is equal to twice cos squared half of the angle. The half of the angle is 3 theta minus 1. For any other angles. Now, some people were saying they have just joined and you missed the first trig lessons. You will visit my YouTube channel, please, for trigonometry. I've uploaded all those lessons, and make sure that you go and check out step by step how we realized all these items. Then you'll get back to me in case you have a challenge and I see how I can help you.
Teacher, I have a question.
Go ahead.
After the equal sign on cos 4 theta is equal to 2 cos squared 4 theta, isn't it supposed
Thank
to
you
be
so much. Thank you so much. Nice eyes. That was a mistake. I had to half the angle. When I half the angle, it becomes what? When I half the angle, it becomes? Yes, lady who has asked, can you give me this one? Cos of 10 theta. What will it be?
2 cos squared of 5 theta minus 1.
2 cos squared of 5 theta minus 1. Lovely. So the idea is the angle you had before, you half it when you're expanding on the other side where you have the square. Now, this was the case when I substituted for sine squared of theta or sine squared of A. What if I saw that cos squared of A from this first identity is equal to 1 minus sine squared of A? Substitute for the sign here. We shall have cos 2A is equal to 1 minus sine squared of A minus sine squared of A. This will give us cos of 2A is equal to 1 minus sine squared of A minus sine squared of A. Another definition for double angle, of course, can be 1 minus 2 sine squared of A. What does this mean? It means cosine of twice an angle is equal to 1 minus twice sine squared a half of that angle. The lady who gave me for 10, give me for cos of 4 theta in terms of sine. Yes, my friend who gave me cos of 10 theta. Give me now 4 theta, cos of 4 theta in terms of sine.
One minus sine squared of 2.
1 minus 2
2a
sine squared of
2.
2a. Thank you.
Of 2a.
Cynthia, can you give me cos of 6a in terms of sine?
One minus 3 sine squared of 3a.
Ate 3 evuddewa.
1 minus 2 sine squared of 3a.
2 sine squared of 3a. Thank you. Birungi Shakira, cos of 12a. Okay, 12 theta.
1 minus 2 sine squared of 6a.
6 theta. You see, I've changed the angle a little. Jesse, cos of 20x. Half, make it double angle. Now, this one also is sometimes we call it the half angle formula because you're reducing the original angle to a half of it. So some books call it the half angle formula. Jesse, give me this expansion in sine.
1 minus 2 sine squared 10x.
Thank you. Sware, are you there? My friend Sware, I saw Sware. Yes, Sware, you are there. Cos of 14 theta. Sware, what will the expansion be for cos of 14 theta?
1 minus 2
Yes.
sin squared
Sine squared.
7 theta.
Theta. Okay. Okay. So that is the first double angle identity we have talked about. Ideally, we are saying that you get the expansion by, if you're in terms of cos, the answer will be cos of twice an angle is equal to cos squared half of that angle, which is singular angle, now minus 1. If it is a double angle and you say cos of twice a double angle, in terms of sine, it will be 1 minus twice sine squared, 1 unit of that angle, or a half of that angle. So ideally, you are halving the original angle you had before. Yeah. Sometimes they can bring it in this form. It can come to this extent. That maybe, may I had cos of 3a is the same as 2 cos squared of 3a over 2 minus 1. Or cos of 3a is equal to 1 minus twice sine squared of 3a over 2. Likewise, I can have cos of theta. Saufa, what will cos of theta become in terms of cos? Saufa? Naminembe Monica. Namagembe Monica, sorry.
Yes,
In terms of cos? Okay, you give me n. Monique. Monique, you have unmuted and you're not speaking. This is twice cos squared a half of the angle minus 1. Or cos of theta can be 1 minus twice sine squared a half of the angle. Any questions on these derivations? So all these are talking about the half angle of cosine. Okay? Now, if that was half angle of cosine, can we go back and also extract out the half angle of sine? Remember, we had let A be equal to B. Since we let A be equal to B, and the sine of A plus B is actually sine of A cos of B plus sine of B cos of A. You see that we are going to have sine of A plus A as equal to sine of A cos of A plus sine of A cos of A. With that reason, sine of twice angle A is going to be equal to twice sine half of twice of A cos half of twice of A. And this is the definition for double angle of sine. This is double angle what? Of sine. Therefore, we can conclude that sine of 2 theta is always twice sine of half of 2 theta, which is theta, cos of half of 2 theta, which is also what? Theta. One may write it in terms of x, that sine of 2x is going to become twice sine of x cos of x. Now we can increase the multiples from double to quadruple to penta to hecta to as much as you want. Like, for example, sine 4x, it is going to be twice sine a half of 4x. A half of 4x is 2x, cos of 2x. Right? Marcel, give me sine of 6x.
2 sine 3 cos 3x. 2 sine 3x.
2 sine 3x cos 3x. Lovely. Lutuleila, give me sine of 8x or 8 theta. Leila, you have just
Yes, teacher.
changed. Give me
No.
the expansion of sine of 8 theta.
2 sine 4x 4 theta
Yes,
cos 4 theta.
lovely. So far, give me the expansion of sine of theta. So far is absent. So far, you don't want to answer. Cynthia. Cynthia, the expansion of sine theta.
Two sine a half of theta cos
Lovely.
a half of theta.
Thank you so very much. Who else is there? Swale. Sine of 3 theta in terms of double angle. What do you get?
2 sine 3
sine,
out of 2.
3 out of
3 out
2
of 2.
theta,
Cos.
cos
3 out of 2.
theta.
Theta.
Very good. Are we still okay? Is anyone having a problem? Whoever has been having a problem, cram this one, go back and cram this one. Either cram this one or you cram that one. Okay? The reason why I was trying to derive these items is to help you get an understanding, to help people who were not there also before see some of the items we are using so that they can appreciate and look for those items which they never covered when they were away. Okay? Now, the last definition we can talk about here is tan. Remember tan A plus B. Leila, what is the expansion of tan A plus B in general? Lutu Leila, what is the expansion? Yes, expansion of tan A plus B.
Tan A
Yes.
minus tan B.
Ah, this is addition, Nyabo. When it's a plus, it's a plus here also. So plus tan what?
Plus tan B. Plus tan B.
Yes, lay it
Over
down.
1
Yes.
minus tan A tan B.
Very good. Now, because we have let AB equal to B, yeah? Since in this case we are saying A is equal to B, then the tangent of A plus A becomes double angle of A, which is 2A. Now, this is going to be tan of A plus tan of A, or is over 1 minus tan of A, tan of A. This finally confirms that tan over 2A is actually twice tan of A, or is over 1 minus tan squared of A. Therefore, in conclusion, tan over 2 theta is always equal to twice tan a half of theta divided by 1 minus tan to the square of theta. Now, what if I have tan to the 4th of theta? This will become twice tan over 2 theta, or is over 1 minus tan squared over 2 theta. Master, give me tan of 16 theta. Yeah? Master Rijuka, are you still there?
Twice tan of A theta
Lovely.
out of 1 minus tan squared of A theta.
Very good. Birunji Shakira, give me the tangent of 12 theta.
2 tan 6 theta
Yes.
all over 1 minus tan squared of 6 theta.
Lovely. Thank you. Okay, so those are the double angles. In case they set their reciprocals like sec of 2 theta, cosec of 2 theta, cotangent of 2 theta, you just do the reverse, or you just reciprocate them 1 over what we have. Now, you need this information. That's why I've been trying to get everyone on board to give me these answers. Because when you're coming for derivations, for proofs and solutions, when you're going to borrow double angle, you will not need to ask anyone. You will just see that the number is For example, if the coefficient is an even number, mostly we apply it when the coefficient is an even number. The others of the three, okay, even this single one, theta, is very common. The common ones are the 1 theta or 1x and the doubles of 2x, 2 theta and the like. The three in the double angle are rare. They will come back maybe in integration in Backhouse too. But the three has its own expansion we are going to see also. And even the fourth, then the rest you will try to investigate in your free time. But why I'm trying to say this is because in solving solutions of trigonometrical functions, like we did the previous lessons, double angle here is common in even numbers and is common on a singular angle. Even angles and singular angles, that's where it's most common. That's why I was asking you to give me these examples. So before I can proceed to the next item in this line, do you have any questions?
Teacher,
Yes, please.
shall I first go back on page 1? I want to get something. Thank you.
Okay. By the way, in your free time, investigate tan 2 theta from sine 2 theta over cos 2 theta. And see, if you use the same method and then you divide, you still arrive at the same expansion. Yes, you will arrive at the same expansion. You get this one for cos of 2 theta. Then you get the other one for sine of 2 theta. Tan is what? Tan 2 theta is supposed to be sine 2 theta over cos 2 theta. Then you divide everything by cos squared or by cos theta. You will prove that it's the same. It will come up to this one. Now, having seen those even factors of angles, what if we have odd factors? For example, expansion of multiple angles which are odd. For example, cos 3a. Now, cos 3a, you split it into odd and even, which is cos a plus 2a. You see that? Now, this means cos of 3a will be the same as cos of a, cos of 2a minus sine of a, sine of 2a. Now you are experts in double angle. Without opening the pages, who can give me the expansion of cos 2a? Because it is cos, let us get it in terms of cos. Expansion of cos 2a, in terms of cos, what do we have? Randomly, someone give me an answer.
2 cos squared a minus 1.
2 cos squared a minus 1. Thank you. Minus the expansion of sine 2a. We have sine a multiplied by sine 2a. What do we get for sine 2a? That one has only one option. Cosine is the one that has two options. We get, ladies, did you attend? Someone give me an answer.
2 sine a cos a.
Thank you. Now, do you see that we have condensed everything to singular angles? Now, expansion. Cos a times 2 cos squared a, you get twice cos to the cube of a minus cos of a minus twice sine to the square of a cos of a. Right? Now, this will give me twice cos.
Can repeat that.
let me use another color here. This one times this one gave us this one. Do you agree? Then this one times 1 has given us that one. Do you agree? Then this one times sine, you get what? Sine squared. Then this one times cos, it remains cos. Is that okay? Mister, are you happy now?
Yes.
Okay, thank you. So this is twice cos cubed of A minus cos of A. But learners are experts here. Mercy, what is sine squared in terms of cos squared?
1 minus cos squared
Very good. That is what I expect.
of A.
When you see a trig function, which you covered earlier, you already know the function. Don't over ask yourself what you use. You should know what to drop there. But the only experience of this being perfect is attained if you solve all the numbers you land on. When you solve very few numbers, you cannot easily see these things. So expansion confirms twice cos cubed of A minus cos of A minus 2 cos of A plus 2 cos cubed of A. Finally, cos 3A is going to become 4 cos squared cubed of A minus 3 cos of A. All right? It will be I'm going to leave it as your assignment to try it out in terms of sine. You can reach here. Okay, you cannot get it in terms of sine. It will remain in terms of cos and sine because this one can't expand. So that is the expansion of sine 3A. Now this one is not easy to cram, those of us who want to cram. But don't worry, in our country, UNEB allows you to go with the quest with a log table, which has all these trig identities. But for you to have the log table also, you need to know where and when to use it. There's no business of having a log table, but when you don't know where to borrow it from, otherwise these derivations are there. You can quote all the time. Unless if the question says, prove that cos 3A is that one, which can be asked. How about sine 3A? Why don't you expand for me sine 3A? You show. You also become serious class students. Prove that sine 3A is 3 sine of A minus 4 sine cubed of A. You have 10 minutes. Starting now. Try it out. I am frozen. No, I'm not frozen. I'm waiting for you guys to finish the number. Jess, are you done? Jess, are you done? Even Swale, you were saying I'm frozen. This network. You have around 3 minutes. Because me, I want to come and reduce the time. I want to come in and reduce the 3A. The turn 3A. So for you have to give me that proof. And if I go to the turn 3A, I need to confirm that at least most of you have got that result. No one is posting an answer. Are we done? Has anyone posted? They are working? Okay, someone has sent. Let me see. Yes. Yes. Mhm. Okay. Who has this? Is this Mercy? Who has sent me the work?
Me.
Mercy? That was Mercy?
Yes.
Yeah, it's correct. So for the rest of us who have not managed to, the rest of us, where have you stopped?
I've also sent my work.
Yeah. So that is Mercy. Correctly getting the work. Someone else has also said she has sent. Let me check on what Cynthia has done. Mhm. Very good expansion, clear substitution, very good. Yeah. Cynthia, also your work is very correct. The boys, what's up? Okay. It's good that some people have got it. So if you don't, now the other skill I wanted you to borrow was to come and show me that sine 3a, I told you to prove for 2a, is over cos of what? 3a. Since we have seen sine is 3, sine of a minus 4 sine cubed of a divided by the cos, which is 4 cos squared, cos cubed of a minus 3 cos of a. Divide everything by the highest power of cos. You will get tan 3a is equal to 3. Because you want to get what? I want to divide everything by cos squared, cos cubed. I will get sine of a over cos cubed of a minus 4 sine cubed of a over cos cubed of a, all divided by 4 cos cubed of a over cos cubed of a minus 3 cos of a, all is over cos cubed of a. Now this is simplifying to this. 3 tan a sec squared a minus 4 tan what? Cubed of a, all divided by 4 minus 3 sec squared of a. When you express it in terms of tan, you'll get thrice tan of a into 1 plus tan squared of a minus 4 tan cubed of a, all is over 4 minus 3 into 1 plus tan squared of a. Do you see that the numerator becomes 3 tan cubed of a minus 4 tan cubed? I'll remain with 3 tan a minus tan cubed of A. Down, I'll remain with 4 minus 3 is 1 minus 3 tan squared of A. Hashtag proof. In your free time, expand using this technique. Tan of 2A plus A. You must get the same answers. Okay. Any questions there? How much time? 17 minutes. Anyone with Backhouse 1, please share that page which has numbers on double angle. I have some here I'd forgotten. So, whereas most of those ones have been called double angle and multiple angles, we have seen the half angle formula, which came as a result of having a singular angle, and then you half it. This one is what I call the half angle formula. Actually, I did not talk about the half angle for tan. Let me summarize them here. The half angle formula where 1 cos of theta, we saw is twice cos squared theta over 2 minus 1. Also, we saw cos of theta is equal to 1 minus twice sine squared of theta over 2. We saw sine of theta is equal to twice cos, okay, sine a half of the angle, cos a half of the angle. Now, tan of theta will give us twice tan a half of the angle out of 1 minus tan squared over half of the angle. So all these are what we call the half angle what? Half angle formula. They are derived from the idea of double angle what? Formula. Okay. Let's have some examples before the day business closes. Examples. Prove that 1 tan a half theta is equal to sine of theta, or is over 1 plus cos of theta. 2 sine of 2 theta, or is over 1 plus cos of 2 theta is equal to tan of theta. Ideally, these two are the same. They're the same ideologies. Then also prove that sine theta is equal to twice tan a half of theta, or is over 1 plus tan squared of theta over 2. Prove that cosec of theta plus, actually this is cosec of 2 theta plus cot of 2 theta is equal to cot of theta. There we are. The first one. We want to prove that tan of a half of theta is actually equal to sine of theta over 1 plus cos of theta. Because it's a proof, you can start from either side. Now, it's not so easy to come from the half angle going to the double. It is better to come from the twice to come to the half. So we can say from the right-hand side, which is equal to sine of theta out of 1 plus cos of theta. This is going to be half angle sine, you get twice half of theta, cos half of theta, all divided by half angle of cos is 1 plus twice cos squared of theta over 2 minus 1. When do I know that for cos I should use cos? when I see that the proof is tan, the denominator should by all means be in terms of cos. So I make sure I substitute everything in cos. If it was the denominator having in terms of sine, then I would be bringing sine on board. That is how I conclude to easily confirm when to use sine and when to use cos. But of course, it requires you to solve as many numbers as possible to have all these skills at your hands. Therefore, do you realize that we shall have this giving us twice sine theta over 2 cos of theta over 2 divided by twice cos squared of theta over 2, vamush the 2, vamush 1 cos remain with 1, hence proof of tan theta over 2, hashtag solution. I said the second one is also ideally the same. The second one from the right, okay, from the left-hand side, which is equal to sine of 2 theta, or is over 1 plus cos of 2 theta. So you just require only the other ones we derived, or the definition of the cosine and the sine and the tan in terms of half angles. So this will give us twice sine of theta cos of theta divided by 1, because the proof is tan, 1 plus twice cos squared of theta minus 1 vamush. You see that this becomes twice sine of theta cos of theta, or is over twice cos squared of theta. Lose the 2, lose 1 cos, hashtag proof is tan theta. Check the next one. The next one is sine theta. Very interesting example. From the left-hand side, which is sine of what? Theta. Do you see that sine of theta is the same as twice sine of theta over 2 cos of theta over 2? But you think outside the box, the whole of this is over 1. Yet, what is 1 later? Where does 1 come from? Intrigue. Shakira, where does 1 come from? Intrigue in terms of that angle, in terms of that half angle. Mercy, save the day. Where does 1 come from? Are my students available? Jesse, where do you think 1 comes from? Yeah?
Sine squared theta plus cos squared theta.
But now the angle we are dealing with here is not theta, is theta over 2. So it is sine squared theta over 2 plus cos squared theta over 2. Is that okay? Then divide everything up and down by cos squared theta over 2 by cos squared theta over 2. When you divide everything by cos squared theta over 2, see what is going to happen. I think I never wanted to remove this one. Let me rub here. Just know whenever we have to introduce tan, we have to divide by cos. So we shall have twice sine of theta over 2 cos of theta over 2 divided by cos squared theta over 2, or is divided by cos squared theta over 2 divided by cos squared theta over 2 plus sine squared theta over 2 divided by cos squared theta over 2. Vamoosh 1 cos here by division. This one vamooshes totally to 1. Then finally, this becomes what? This will become twice tan theta over 2, all divided by 1 plus tan squared theta over 2. Hence proof. Okay, the last one. The last one says cosec of theta plus cot of 2 theta. I can let it be equal to the left-hand side. If I let the left-hand side be that, then the left-hand side will actually be equal to 1 over sine theta plus cos 2 theta. Hey, this is 2 theta, eh? Over sine 2 theta. You see that this becomes 1 plus cos 2 theta, or this is over sine of 2 theta. Now, because the answer is in terms of cot, the denominator should be in terms of sine. Then the numerator should be in terms of cos. So expand the numerator using cos, you'll have 2 cos squared of theta minus 1, or is over twice sine of theta cos of theta. I vamoosh the 1 by subtraction. I'll realize twice cos squared of theta, or is over twice sine of theta cos of theta. This will give me tan of theta hashtags. A, not tan, it gives us what? Cot. Gives us cot of theta. Hence proof. Any questions? Who has discovered the page in Backhouse 1? There is I told you there is a master in pure math book. Those of you who are interested in it, let me get some numbers from there. This is the book. It's quite big. It comprises of both Backhouse 1 and Backhouse 2. I told you those who are within Kampala and Wachiso, you can easily get delivered to. Those who are up country also, we can arrange a bus to deliver your book. But let me first see how I can send some of these numbers for you to look at. If no questions. Yeah. So if no questions, we can call it a day. Let me send the work. You take a look. Someone also send us work from Backhouse 1. All of you have UPM, Understanding Pure Math. Please visit there. Check on double angle formula. Check on half angle formula. I also got my Tranta. I'm going to send you some interesting numbers from there so that you can also have an enjoyment of solving these numbers. Okay, with that, you can call it a day, and then we meet next week. Have a blessed weekend.